Hello and welcome to our another 0 to 3D session where we're going to cover 3 topics. First is animation inside of the using Three.js. Second, how to prepare model inside of Blender. And third, how to use this animation inside of the Webflow. And we have Federico Walla, who is going to cover all of these 3 topics. Hi, Federico.
Yes, hello everyone. Thank you, Sergey, for having me. I think also we're going to learn a really important trick, which is going to be how to actually host 3D model inside of your Webflow assets.
That's sweet.
Last time we started from the developer starter, or if you have downloaded the repo, you're going to find something along these lines, and you can continue from the live file from the session one. To be able to provide the separate files, I'm going to do it in a new file, but the live2 file is just a copy of what we had before. Same as last time, you're going to open the terminal and just drag the folder inside, press enter, so you're now in the folder, and you're going to type npm run dev, which is going to spin up your server for serving the code inside of your Webflow project. Webflow project, again, is available as a clonable, but it's pretty simple. The only thing it has inside is a single embed code with a style tag and a div with an attributes that's there to make that into a canvas. And the only other parts of it is you're going to have the script with the tag that your starter from Finsweet is going to provide you, and you just put it in before the body tag. Then you can save, you can publish, and you should have your project running with the 3D model if the code is all correct. Again, best would be to open the console. Now my console is a little bit of a mess, but there's no worry for now. And the code we did last time, we imported a few things, namely Three.js, the controls, which is the thing that allow us to spin the model, the GLTF and texture loader same from Three.js, but they need to be imported separately. And then inside of the Webflow push function, we call a function that we wrote. It's called init3d. Selects the div we gave the attribute to. We created a scene. We created a camera. We created a render. We set the render sizes and so on. Created a cube, created a geometry. Then we didn't add the cube because we added our model. We added the controls. We positioned the camera, and then we had a function that loaded the asset. This was the function that loaded the asset. So we had a texture and a model hosted in Webflow with the trick that Sergey was mentioning. We have made a couple of simple asynchronous function in JavaScript to be sure to have the model loaded before everything else was happening. And we made the loop function for animating and seeing the controls. Now, I also forgot to restart the server. So that again. And we got to this point. So we have a 3D model inside of Webflow, displaying in a canvas with controls that we can move. Now, this session is going to be about animations. And it might seem a bit scary at first, but there's really just a couple of concepts that we need to know, because thankfully Three.js provides an amazing animation system. Now, in general, for reference, what we will be covering is also explained really well in an article from the Three.js website as well, which I suggest everyone that's going to attempt to do anything with Three.js really refer to the documentation, refer to the example, and basically copy and paste things from there, because that's the best way to do. And like Three.js is a gigantic library, so you really don't have to memorize it all. But so I think what we can do to start is we can start with removing a little bit of the thing we did last time that we don't need anymore. So this cube that we are not putting in anymore. And that is it. We also maybe remove this console log so we don't say hello on top of the console every time. So there's two components on animation in Three.js on the web, at least this kind of animations, which is animated models to be specific. And those two components is there's one part that happens offline, which we're going to take a look at in a minute, which is the Blender side of things. So we have a model that also has an animation and gets exported in a format that allows for the animation to be displayed on the web. And so we're going to talk a little bit about bones, keyframes, and how to export from Blender an animated model. But then there is also a part that happens in the browser, to be specific in your code, which is going to be the part that is responsible for first load the animation, and we're going to see that that's pretty easy. Then to be able to reference the animation you have in your model and all the controls you need to play and pause and different ways to play the animation. There's also ways to play in with GSub, for example. We might do a little bit of that maybe at the end if we spare some time. But in general, like how to make an animation run. And so the browser part is again split in two ways. There's the loading part, same as loading the model, but loading the model and the animation. Now, right now, we have a function that loads the model, which is here, that we did last time. You shouldn't really worry about that too much, but there's going to be an import like these pieces of code you can reuse in every project, and they're always going to be the same, but we're going to be doing a little bit of a modification in here. But so what you see here, we are loading from an URL a GLTF or GLB model. In this case, they can be used interchangeably. But my suggestion is always to use a .glb file, just because everything is inside of a single file. Also, for example, here we are using, we are loading the texture separately, which is another good thing in terms of performance, especially to not have the textures tied to inside of the same file. But that's on another, like that's maybe a discussion to have in a different moment. But what we are seeing here right now, so what we are doing, what this function is doing, even if you might not be extremely familiar with the JavaScript itself. So we are calling the model loader that we imported, and this model loads a GLTF, and there is a callback, so this gets passed up to the other part of this function. But what we are currently doing is we are exporting the gltf.scene.
When I think about animation in 3D, I think it in two ways. So the one way is I have the face of the model, like let's say I see it front, and then it turns like in another direction, or I see it from another angle on some trigger, like, section in view, this kind of stuff. And another animation is when this robot, for instance, can really move his hands, his head, and his hand can follow the mouse cursor. This is like really next level animation. Like it's interactive model. It's not just like turning like you would do this in Spline. You could do this simply in Spline. You just to have two different phases and you just like play between. And we talking about like also we are going to cover the second complexity of animation where you have bones and the robot can follow mouse cursor.
So like one animation is just moving the object inside of the viewport. Like you scroll down and this thing spins to one side, spins to the other, spins on itself, can do a lot of different stuffs. And that's pretty easy. I think that you can do quite easily also in Spline because it's just going to be triggers and stuff. Now, controlling the code and doing it in Three.js is probably going to be more performant, but probably for really simple animation and just like moving things around, it's kind of comparable, at least I'd say. Now, a thing that Spline I don't think has access at the moment is like skinned mesh. A skinned mesh is a mesh that has bones, skinned because it's intended as if the mesh was the skin, and there's bones, and the bones control all the pieces of the model based on transform matrices and weights, basically, without getting too technical. But when you have access to bones, you can do two things that would not be possible to do easily directly in browser and, for example, with Spline. So one, you can have animation done, for example, by a professional animator, or you can do them yourself in Blender, for example, and just have lots of different animations. You can see an example of the multiple animation setup in the Finsweet website as well. So, for example, when you hover over, like, there's two animation, for example, in the agency page. You scroll down, you have the first type of animation where it's just you move the camera basically and you look at the object from another angle.
If you show Finsweet site right now, we don't see it. We see like so. If we would not have bones and everything, like if we would do in Spline, our tiger would just like stay and you can see him. That's it. But
so
on Finsweet website, you can see he is like walking, right? And he is roaring when you move when the mouse over the agency, he is roaring. This is playing another animation. And when you hover on products, you see the like elephant is walking, and on community, dolphin is jumping. So this is all different kind of like animations that I'm playing, and we have triggers on buttons.
Yep. And like the other, like the first type of animation can be, for example, just moving the mouse left to right, and this is just spinning the scene basically. But for having a walk animation that goes into a roar animation, these are two different tracks, and we are playing between them. Where we left off is what we were loading before. We were loading GLTF, is the object that was being loaded, and then we were returning from the promise that loaded the model, the scene. Trick is, if we console log it, the GLTF has more, like in the loaded GLTF file, you're gonna have more than that. Namely, what we are returning is the scene. So this object, and we're accessing the scene property, but it also has an animation property. And inside of the animation, there's the main formats for which skinned mesh and bones animation are moved from a program like Blender inside Three.js, and it's using this what's called an animation clip. It's called an animation clip in Three.js, but I'd strongly suggest anyone to stay as further away as possible than doing this in native WebGL, because just looking at a set of bone matrices is crazy and crazy complicated. But what we need to access, so we actually already loaded the animations. What we need to do is access the animation and have a way to reference them in our code. So if we go back to the loader here, what we can do, same as we are doing here, is going to be animation equals GLTF animation. And as we were passing down the results, we also have the animations. Now, this result comes out of, so that we have a function that's load, and then it returns the two loaded thing. Now we'll need to get from the load model function, we need to get more than one thing out. So what we are gonna do is going to be, I think we can leave it as robot. And what we can do is we can do this and this. So right now, instead of just coming back as a single variable containing some data, it comes back as another object with both result and animation in. Now, this we should probably rename to scene. So we are retrieving those two things. Now this is going to crash the app, because now the robot that that we are referencing here. So if we console.log the robot, we can see it's instead this object with two properties. So the robot is going to be, I think what's the best way to do it, and the simplest way to do it, I think we can just return this. So the data-robot is going to become data.robot.scene. And now we should get, nope. I think so let's just console log what's coming back. Once again, we are, so data-robot.theme. No, because I'm using yap. Let's do it like this. So the robot is going to be data.robot.scene, and we are going to remove it from this, and from this, and from this. So we just gave a different name to this robot, and then we also have animations. Good. Is going to be data.robot.animations. So if we now get back to only console logging the animations, and we try to get rid of a couple of other console logs that we don't have anymore, thankfully. And so we are actually referencing now this set of animations other than the robot. So with the robot, we're just doing the same thing we were doing last time. So we are looping through everything that's in the robot. And if what's in the robot is a mesh, which is a 3D object that we can add, and which is the type of 3D object that's composed of a geometry and a material like we did last time. And we are, if the child is a mesh, so it can have a material, we're just adding a material and setting the texture to the texture we loaded. But now we also have the animations, and this child is everything that's inside of this robot object. Now, without spending too much time discussing that, a 3D object loaded through GLTF is what's called a scene graph. So it has a lot of different things, namely are like transforms that are basically pivot points and reference axes, and can have a lot of stuff. What we also can have, as we were talking about it, is, thank you, Copilot, we can console log, for example, this, and inside of the whole scene, there's also bones. And bones is what we were talking about earlier, and it's what's going to be animated. So, for example, we console log the bone, there's going to be lots and lots and lots of bones. We're going to take a look at the model in a minute to understand what those bones are and what role they can play. But this is a good way to start visualizing what you're actually bringing inside of the browser. And all these things are things you can interact with and play with and modify and, for example, tie to the mouse movement. And it's the same way we are doing in the Finsweet website, the tiger that moves its head and follows the mouse. A good thing to start to think about here is you don't have to do all of this yourself. Like on Sketchfab, for example, there's a lot of really well-made models with really great animations already that you can use to play with. And there's also a toggle there for you, so you can search for that. Usually, if you want something really, really professional, an animator does it. But we're going to see in a minute that you can also easily do it yourself. It's just going to take a little bit of time, especially to learn at first. But also how me and Sergey are experiencing a lot and have experienced a lot. Also, really great animation from Sketchfab is not necessary. Like they might not work as you expect, especially because they come from different programs that use different ways to animate and constraints and stuff. So just be aware, not everything that looks amazing is going to look amazing in your Blender file.
Right, complex animation can be messy in Sketchfab if you just like put it into the Blender and try to play on the web. But if we're talking about this animation where you just connect a bone and you control it with mouse cursor, that's probably better to do it yourself without getting from.
Oh yeah, no, that I
else.
understand.
Yeah,
that you need to do it yourself, because I think we can do really quickly already like a bone animation, and then we jump into Blender, so we also look what the bone was. So I think we can console log the name of these bones, and so these are all the name. All these objects have a name, which is really convenient because you might need it. Now I know what I'm looking for because I've looked at it earlier, but I also when we are in Blender, we like those names are the names that are given to it in Blender. So the BB neck is a bone that has its influence on the head and is basically rotating this vertical thing that controls the neck of this model. So what we can do, and you should do it. Where am I calling the load function? Am I calling it? Yeah. So we will be declaring load just to have it to have access to this in the global scope and not only inside of this function. So what we'll do is let neck bone equals, I think null is going to be good because we don't have anything, but I also don't want it to just be, I think it's going to be the same, but so we declare the bone outside, and then what we do is if the child dot name equals, and we didn't, I think we were baby neck, what we can do is assign this bone that we found that has the name of BB neck to the variable that we declared here. So if everything is not crashed, we should have, we can just check it. We can console log it here. Console.log the neck bone. And now we should see, why are we seeing all the bones? Oh, because I'm doing it inside of the loop. Yes, sorry. So let's do it outside. I was doing it when it was going through all the meshes. So you're just going to have one bone that's going to be a bit of a complex object. You really don't need to worry about most of those. The only thing is the correct name, so we are referencing that. And now what we can do, for example, is in the animate function that runs constantly, what we can do is if the neck bone exists, so it's not null, we can do is different than null, just to make it a little bit clearer. But this way is going to look like the exorcist, I think it is. So we're going to have a, okay, no. Oh, yes, sorry. We need to declare it before we're calling the function. But what you're going to see is that this bone we are controlling inside of JavaScript. So like, yeah, this is a bit of a weird one.
Yes.
I think what we can do is, yes, this kind of works. It should just move right to left and so on. And so this happens because, without, again, getting too much into the weirdness of web animations, the sign function goes on and on. And so it basically +1, -1, +1, -1, plus some value that Copilot decided that I think someone already used and who are looking quite well. So we're going to stick with those for now. So what is happening here? We are actually, and this is a good time to jump into Blender, because we are controlling a bone. And this is one way to do it. Like, this is exactly what you would do. You would just add some way to listen to the mouse movement, and you move it with the mouse. I think it might be time to jump in a little bit into Blender to actually understand what is happening in this case. and then we can get back and maybe like attach it to the mouse.
Sweet. Yeah. Let's jump to Blender. Very exciting. Like Blender is very complex too. When I open Blender, I always freak out because like the number of all the drop downs and buttons and all those like small icons. And I'm like, I will never learn the Blender. But the point in Blender, like you don't have to know everything. If you know at least 20% of the Blender, or if you know like 3, 4, 5 tools, you already kind of like can work with the Blender. But like, you know, you can watch some tutorials on YouTube and this kind of stuff, like, but it's really like you don't have to know everything, and you never use everything in Blender, but yeah.
Yes, as Sergey was saying, like Blender can be and is actually quite intimidating in general, but that's because of a really specific feature of Blender, which is it does everything. Like conceptually it can be a program that you can use to, and you like without ever needing to go out of the program, you could make a whole animation film by yourself. It does modeling, it does animation, it does texture painting, so you can like custom textures inside of Blender. Now it doesn't do everything the best, but it's getting there. And so you really have to know what you have to know to do the things you're interested in. So this is the 3D model we're seeing in browser. What we're not seeing in browser, but it's still there, is those weird spikes things. That's what's called bones. And these are the one that we are controlling. Now, bones, in this case, are inside of the model. So, and they are controls for the mesh. This is what's called the rigged model. So it has a rig. The rig is those things, and you can select things, go in pose mode, and you can animate parts of the model. Now, I fear that if I put them like this, you might not really see them. I also gonna select the in front tab. So what are we doing essentially inside of Three.js now is referencing those bones and rotating these bones based on a function of time. So this is what we are controlling. And this is a pretty complex rig. This is a model that's freely available online as well. So, which is an amazing model to be freely available. I think we're gonna credit the artist as well at some points, but it's released for free. It's already rigged, and it's an amazing model, especially to experiment with this kind of stuff. So inside of Blender, what the animation that we were talking about earlier is in the animation panel. What we have is all those bones have keyframed values, and this is what they're doing. So this is the bad animation I was referencing earlier that I made a little bit randomly. Maybe it's also a little bit too short, but it's good for explaining what's happening, basically. And what you see here, it's called pose 1, is the same animation that you have in the like this animation here with this name is, if you look at what we are importing here, the name of this is the same as this. This means this weird animation is available for us to play in the browser. And this can be anything. Like this I made. It was a really quick and dirty one. But what you can do, and we might want to try this maybe in a little bit, is you can make a lot of different animations from scratch. And like your mouse could only not track, for example, the bone and the rotation of this bone, but you could make an animation that doesn't need to it can be played with other things than time. So you can also, for example, export an animation that does one thing when your mouse is fully to the right and another thing when your mouse is fully to the left, for example. Or you can import different states, but in a way more complex and like intricate way, and just link them to different scroll sections and things like that, which is another cool trick. Like the main thing is, and I think it happens a lot in those kind of web 3D animation, is you're trying to maximize a pretty good but still reasonably small amount of tools to do anything you can think of. And you can see incredible examples around the web. So yeah, this is the model. This is the animation that we are exporting. It's a bone-based animation. So again, this dude is saying you can modify things. This is the basic rig. And I think let's try and play this animation that we imported in the browser. And then if there's time, we can try and make a new one or tie the bone to the mouse. Let's
and Federico, if I would want to, like, let's say I have my 3D model, right? And I want to add a bone. How would I do this, like in Blender? Do you have a quick...
So rigging is a little bit of a difficult topic, but it's essentially you have a 3D model somewhere that can, in some way, articulate. Sorry, my screen is super big to do this. So you have a 3D model that has enough subdivision to do things like that. What you're going to be able to do is to add an armature. You can move it. I want it in front. You can move it like this is now inside of the model. We just seen it. I think we can do it like this, so maybe less confusing. So it's in the model. And if you do something like this, this is not going to look good, but it's going to be a good way to demonstrate this. So you have a model. You can, well, let's do it in an easier way. So you place your first bone, you hit E to extrude. You extrude a second bone. And what you can do is you're going to click on, let's get back to in front. So you click on this, you click on this, you hit Control or Command P. That starts the parent tool in Blender. There's amazing tutorials on YouTube as well for free that go into this way better than I do. But I think if you do with automatic weights, what you're gonna get is something that's gonna look bad, but basically it's gonna be tied to, so the bones are now controlling this geometry that we are seeing. So it's pretty easy. There are also, again, if you look for Blender rigging YouTube, you're going to find amazing tutorial that like in 10 minutes, they're going to explain to you how to rig. There's also basically plugins that allow you to rig a human-shaped figure in like 10 minutes, which is crazy if you think about it. But
Nice.
This is the base of rigging. And this could be another model that you could export and use inside of a Webflow project if you want a really weird blob-shaped thing. But like this, you give it a really nice material, and then when you move the mouse, this thing's gonna move. Might even be funny.
It is funny.
What? Maybe you want to subdivide it a little bit and just... So yeah, this could be like, these are really fun things that you can do.
Yes. And now you put two eyes, you put like smile, you know.
Yeah,
like
exactly.
Singing a song, and it's just like, you know, dancing.
Exactly.
Really cool.
Yes. And you're already there.
Nice.
So, but yeah, you can rig it pretty easily. Again, I suggest doing tutorials. I'm also absolutely not a specialist. I do really simple rig like the one with a cube, or I tend to use already rigged things, or I work with some 3D artists that are really good at rigging. I'm not particularly good. I improvised myself a little bit in some cases, but if you want really good animation, usually it's either a professional or a pre-made model. But so yeah, we have this pose one animation, and this pose one animation is somewhere inside of our code now. I would skip how it actually works and like what is an animation. It's going to be the gigantic array of values that make a relationship between the bone and the model, and values that rotate the bones. But we're going to get into a really difficult and tricky. Okay, so this dude is still, his head is still spinning. It's going to get to a really tricky territory, and I think you really don't need to know that well to just do what we are about to do. You need somehow to control the concept of time. Thankfully, Three.js provides an amazing class that we're going to call clock in animation. And again, this 3, as we were importing everything else at Three.js.clock. And this thing, it's kind of underused, but it's the simplest way to make animation aware of where they are in time, especially because you don't really just need a linear time, but you need the elapsed time since the last tick. A bit complicated, no worries. You're going to call this class with a function on it, and it's going to give you the time that you need for this. Then you need 2 things. One is an animation mixer. But the animation mixer needs to be initialized with the model he's going to animate. So for now, we are again setting it to null, just because we want to be able to use it inside of here, but we are going to actually start off after we've loaded the robot. So it needs an animation mixer. I think we can separate those stuff just because our animation setup. So you need a clock, a mixer, and you're going to use a function to link the animation to the mixer. So first thing first, when the model is loaded, so we are awaiting for the model to be loaded, model gets reversed, we find the bone and we reference it. And after all of this, initialize mixer after robot is loaded. And so, yes, exactly. So again, from Three.js, there's a 3 animation mixer. Now, just to make sure when you're working with animation, because if you do something wrong, I'd suggest you keep on going back and checking. Now, I know this works and it's pretty easy, but when you work with animation and the animation triggers, but it triggers in a bad way, your model can be sent to nowhere land because the animation is not triggering properly. So keep on checking where something is going wrong. So you're going to have an easier time later on trying to figure out why it's not working anymore. And another thing you're going to need to do is, I think sorry, I have my mouse is scrolling a little bit too much. So this is the animation mixer. The animation mixer we need an action that the animation mixer can play and that we can do things with. And this is called that there's a method on the mixer. So we can declare yes, exactly. So this is the mixer we just created, and the clip action is going to make the animation in this case, the first animation from the array we declared, we loaded earlier from here, and that we are returning up top these functions. So if you remember the animations where an array, see there's 2 square brackets around it, is just one element because there's just one animation, the one we were talking about earlier. But just for reference, is still an array, even if it just has one element. And to access the first element of the array, you're going to need to do this. So 2 square brackets and the 0 number, which is the index 0. So the first element of the array. And this is going to create an action. Now, what is an action? If we console log the action, this is the animation action, and there's a lot of stuff in here as well, because again, Three.js is providing a lot of utilities to make this thing easier to work with. So you're gonna have ways to smoothly transition from one animation to the other. If you're using more than one, there's how many times it gets repeated, if it's looped, if it's enabled, if what should happen when it finish, how is it scaled with respect to time. So it's like, how fast does it move? There will have somewhere rotation, I suppose, a duration, I suppose, but the duration might be inside of the clip. So this animation lasts 2.5 seconds. Don't take it at face value, like the duration when you export from Blender and you get it inside of Three.js are most likely going to be a little bit different. So just be aware. Like my suggestion would be always treat animation as if they were something that goes from 0 to 1 and just adjust accordingly. So if you want to play it, for example, maybe with GSAP, so just have a twin a value from 0 to 1 and multiply it by the clip.duration. So you're always going to know that's going to play 100%. But in general, we have this action that it's been initialized by the mixer. So the mixer also knows about it. And what we can do is get back into the loop and do a similar things that we are doing here. So if mixer is not null, so mixer we initialize as null, but when everything is loaded, actually is going to have this animation mixer in. What we want to do is mixer, thank you Copilot again, mixer.update, which means mixer, time is passing. And what we were talking about before, get delta means get me how much time has elapsed since the last time the animation loop ticked. Again, without needing to get too complicated. This is the way the mixer keeps track of the global time, basically. Now, if we do this, we're not going to see anything. We're not going to see anything because Three.js is a good software, and this action exists, is in a mixer, is played, but we need to play. So, okay, again, thank you. So if we click action.play, this dude is doing the weird animation I gave him now. So this is the same of this. Reasonably in the same time now, because this is, again, let's not talk about time, but for example, so it's doing this weird movement and animation. A good way to control time in a global way, even though it's not the best way, but we can keep it for now. So this clock at delta returns a value. If you multiply this value for a really small number, this is too small probably. So the animation is going to be really slow, for example. And so
it looks like a grandma catching his grandson, like taking apple pie and like, what are you gonna do here? Nice.
Yeah, I don't know why. I think it, for me, was probably the eyebrows. Like the fact that the eyebrows actually had the bones and could be animated. I wanted to like do this weird like eyebrow go up type animation, and I feel it was fitting with him being a bit unhappy. I don't know.
It's pretty cool. Yeah, it's pretty cool. Like eyebrows definitely gives him like more emotions, even if he got only one eye. This is pretty.
Yeah, no, eyebrows are amazing. I think the person who did this model was actually like ready for it was ready for I think they were actually making it for a film, but then they abandoned the project and the guy just shared it for free. But the model, like even the rig is incredibly good. Like I've worked with a lot of rigs and this was like really, really well. Also really good thing is it was created from zero. Like the whole character and the animation and the rig were created in Blender. It was really easy to work with. You just take it into Blender. And Blender is one of the best programs when you want to work with the web, because it has like native GLTF, GLB exports and stuff, because there's no issue. Blender is open source, so it doesn't really have a lot of the restrictions and limitation that commercial program have, because like GLTF is technically a Kronos, which is owned by a company, and a lot of programs like Maya, for example, I don't think they have a native GLTF export, but GLTF is the best format you can get to put models with textures and everything on the web.
Yeah, this is important that this is like best for the web. I think this dude can be easy like hero for Pixar movie. Like he's so cool.
Yeah, no,
And
again,
if we're talking about performance, like what is like important thing to know about performance when you look into like bringing 3D model and you look to get this 3D model from, you know, Sketchfab or whatever, like what should I look for in terms of having like good balance of performance and animation in Webflow, in web?
Performance is a really good topic in this case. Like what you look for is small amount, the smallest possible amount of polygons. Now in Blender, I think somewhere you have statistics that tells you how much your model is, how much polygons and things your model have. Now this look like really big numbers, but like GLTF and GLB as a file and also WebGL is really, really powerful. Which means you can get away. What you should look for is vertices. Now, it might be a bit small. I don't really know how to zoom on this, but this like you look at vertices mostly. Like the vertices is the thing that's the most important. In general, the smallest amount, or triangles. Triangle is probably the correct one to point out in this case, because it's going to be a GLTF, so meshes are going to be triangulated and so on. This is why it looks so bad. The original model doesn't look that bad. It's all quads and stuff, but we exported and re-imported as a GLTF, and we are looking at what actually is the model in the web. And just for reference, maybe it could be, I think we can do... this. This is the same geometry we were looking at in Blender, if you see. So like this is actually what gets into Blender. Just know that your model, when converted to GLB and GLTF, will be triangulated. So a lot of this thing is going to happen. But in general, if it doesn't cause issues when it's inside Blender, even if it's quads, it's not going to cause issues when it's inside of Three.js or WebGL. In general, yeah, the smallest amount of polygons is always the best, just because the way WebGL works is it's going to loop what are called the shaders, which might be a really advanced topic for a really far away in the future session. Maybe if you're going to do season 2, but basically what was going to happen and how WebGL draws things is the Unreal Material has 2 shaders. We are GPU programs. One loops once on every vertex. So every time you see a dot, a program is going to run and calculate the position of this. And this is also how the bones animation are happening. And then another shader is going to run for every pixel we have on the screen, and is going to learn the is going to get this information from the vertex shader. That's the one that runs once every pixel, and based on that is going to compute itself and tell a renderer what color that pixel on the screen should be, taking care of lights and all this kind of stuff. But again, just to give it on the simpler side, this is how you import an animation inside of Webflow with Three.js. We want to do a really quick mouse follow animation. You're going to need 3 things. One thing is going to be a mouse object that's going to hold the X and the Y position. So then we're going to need, exactly, thank you. It's going to be a mouse move event listener. That's going to be like this. And what we want to do inside of here Now this is gonna be, I think, bad, but mouse.x. What we want to do, because like the element listener for mouse move is gonna give you basically the value of the pixel of where your mouse is. So what you want to do is exactly that. That's perfect. Do it also for the Y. So what this does is takes the E from the mouse position, divides it by the window inner width. In this case, is going to be in this space. So what this returns is a value from 0 to 1, 0 being the mouse to the full left and 1 being mouse to the full right. And then times 2 and minus 1 is going to make it so the 0 is actually going to be in the center, the minus 1 is going to be to the left, and the plus 1 is going to be to the right. What we now can do with the code we had before, we can make the rotation of this. I think we can also just explain what's happening here. This is like a really important function in all the creative development type thing. So let's just console log the mouse.x. This is +1 when it's to the right, see around 0.9, and -1 when it's to the left. So, and what you're doing with this value is telling this bone, the neck bone, to rotate based on this value. And the other thing you can do is same thing, neck bone rotation X, mouse Y. This is going to be a bit weirder. It's probably flipped, but we can make it a minus. So this thing now is going to follow you around everywhere, also as it's still playing the animation. Now that might not be wanted necessarily, but you can mix and match. Like the animation mixer can play conceptually an infinite number of animation. So there's also like really complex models. Like consider this started from games. And for example, what you're controlling and doing here would be you have a run animation that's going to be attached to the move forward key. At the same time, you're going to be maybe the upper torso that's going to like hold the gun or shoot a ball or whatever. So you can play more than one animation. You can fade between different animation in different ways. You can fade from a run to a walk. And while at the same time, in a model like this, for example, the torso could be completely detached and just move with the run animation in an idle position. But when you click your mouse, this could raise his ends, and then mix and match a lot of different things. And it's all done through this technique here. So you're gonna find the correct animation, decide if you want to play, and like create controls that based on triggers, they do different things. So it's gonna be there's a, if you wanna see this, so set timeout, we can just quickly see what I fade to. So action dot fade out, and it takes some time to happen. So if we make a timeout after, let's do 2 seconds where I started, so the animation starts, and what you're gonna see is it's gonna get back to the 0 animation when that happens, hopefully. Yeah, let me just remove this delay because it does this. And now it goes back to the stop position because the animation faded out. And what you can do is while an animation fade out, you can fade in a different animation and those will be interpolated. I think there's also a crossfade too. So you can just give in 2 animation at a time and it's going to fade in between those things. All this information you're going to find inside of the Three.js documentation to do this kind of stuff.
So we have covered like 3GS animation. We have covered how to prepare model inside of the Blender and how to connect the bones, right, and how to control bones. So like the last step for us is to bring this into Webflow.
This is technically already in Webflow. My suggestion to properly do that, since this model is already the model that was in the inside of the Webflow project. I think this is also again public as a clonable. So you should be able to clone this. Also in the GitHub repo, you're gonna find the original asset in Blender.
Nice. And let's review this trick that we mentioned like before.
What you want to do, starting from here, is going to be you select all. So, namely, you select both your bones and your model. This is really important. Then you're going to hit File, Export, and you're going to find GLB, GLTF. Sorry, my interfaces might be really small, but so you're going to be prompted with a few things you can choose in settings. So the first I'd suggest you is remember export settings. So your file is going to remember how you're exporting. This is really important. You want to include selected objects. This just makes sure that everything else you have in the scene is not going to get exported. This is another good thing for performance. Like, be aware of what you're exporting. Also, because given the way it works and a scene graph work, you want to be able to find your object as easily as possible. And this happens if you know what you're exporting. Transform, you can leave it like this. Just be aware, as we said also last time, Blender is Z up. So this is like the vertical one is the Z axis. In WebGL, the Y is the Z axis. So this is gonna make sure this is already checked, so you don't have to worry. Then the data, again, my suggestion would be to don't export the materials, because as we did, we are exporting the texture separately, so we can optimize it and make it in WebP and make it in compressed formats. So it's gonna load faster. So you don't want it to be there, but already in the boilerplates, everything is good. Lighting mode, you don't really need to worry. You don't have lights and you're not exporting light. Compression, I'd leave it for another topic, because to load that is difficult. But the important thing is going to be in the animation tab. So you want to have the animation checked and all the standard things are good, which means it's going to export as animation. Shape keys, we're not using here, but I'd suggest you leave it on, especially if you're downloading a model animated by someone else, because it might be using shape keys and just helpful things for the animation part of the model. And skinning are the bones. And these are all the bones. What you can do is let's do robot v3.live, which is the live session. You're going to hit export GLTF 2.0. And what you're going to find in the folder, which is, this is all available online. You're going to have this robot v3 live.glb. To use it in Webflow, you're going to have to change the file name to .txt. You're going to tell him that we want to use txt. So this now becomes a txt file. And what you want to do is, I don't know if I'm going to be able to drag this. I think so. You can drag the model as a txt in the asset panel. So it's going to load. It's going to take a minute.
Nice. I wish you could do the same with JS files. Just put them here and host.
Yeah, sadly, I don't think it can work. But no. So you now have the GLB file inside of the of your Webflow project. And what you can do is you're going to just swap it for what we have here. So with a new link, and hopefully, if I haven't done something really badly, this should work the same, because we just exported the model and everything worked.
Nice.
So then again, using the Finsweet developer starter, you should know, well, Alex gave us an amazing rundown of how this does work, but what I'm gonna do on my side in this case is going to be npm run build. So now we should have, I think it's in dist. And this file is the file you can use to deploy things. Now, you're going to have to drag this somewhere else. Let's do a new folder. Let's call it Webflow. You just take this, put it into this, and /2. You can push all of this to your repo. In this case, not mine. It would be better, but then is you're gonna see a lot of stuff you should not be seeing.
We pretend not looking.
Thank you. Yeah, exactly. Thank you. So we're going to have inside of session 2, there's gotta be, was it live 2? I suppose. there is a Webflow. So you can take the link to this file and just use JS deliver to host it inside of Webflow. So what you can do is you can swap out this. I'm just gonna save this for your live link. And this now should be there for everyone to see. I don't think I've done it in one go, but maybe it is working now. Let me stop. Well, this is already stopped. Hopefully everything should work now. Still, because now we have, yes, and this is online, like with this link, I think everyone should be able to.
Awesome
Project, because you also deployed now. So this is how you deploy code in a convenient way using GitHub.
Thank you guys for watching this video. I hope you enjoyed the video. I hope you learned something new about 3D. And now what you can do, you can animate your model inside of using Three.js, preparing the model inside of the Blender and host it on Webflow natively with super cool trick from Federico. Thank you, Federico, for providing such awesome information for everyone. This is great value. Thank you for being with us.
Thank you again, Sergey. Thank you everyone for hosting me. I hope everyone enjoyed. And also remember to give the video a like and subscribe to the channel, because I think we're gonna be having at least one other session together.